Hello, in this video we're going to take a look at another type called double. So you might wonder what you're supposed to do if you have a floating point value. So instead of having 7 or 5 or 1329 or whatever, you have something like, let's say, 8.3, something with a point in it. And for that there's another type that you can use called double. In fact, there are at least 2 different types. Well, in a way there are a number of different types you can use to do all of these things, but we're just covering some of the most basic, most common, most fundamental types here. And incidentally, before I get started, I just want to point something out which I'm going to return to later, which is that if you have multiple projects like this, then you want to make sure that you're always running what you think you're running. It's a bit easy to get into the habit of clicking that run button and then running the wrong thing by accident. And to be sure, select the class, so app.java in this case, containing your main method before you hit the run button. And if you want to be absolutely sure, select it, right click it, go to run as Java application, and then you absolutely know what you're running. Otherwise you can get quite confused quite easily. Also, by the way, you can, not only can you sort of contract projects like this, but you can right click them and close them like this, go to close project, and then you can open them again later when you want to. We're going to look at this stuff more later on anyway. I just wanted to mention that. Okay, so doubles. If you want a floating point value, you can't use the type int. So I can't write int, what should we have here? Maybe height equals 1.8. So that's not going to work. We get an error here, and if I hover over the error, it says type mismatch, cannot convert from double to int. So this is what we call a literal value here. It's we can also say that it's hard coded. It's a value that I've actually coded into my computer program, a literal hard-coded value. And intrinsically, by default, it has the double type because it's got a point in it. We need to use the double type to store it. Incidentally, in the USA and the UK and some other places, we use a point. So we say 1.8, that sort of thing, to indicate fractional values like 0.8. Large parts of Europe apparently use a comma, but we don't do that in Java. As far as I know, all versions of Java are the same. We use a point to indicate a fractional value. Okay, so let's write here double. Now we've got something that will actually work. Now we've just got a warning, which is saying that we're not using it. And we can output that out just as we did with integers. So let's say height is plus height, and let's try running that. There we go, height is 1.8. We're going to start doing some stuff with this, but I'm going to leave it there for this tutorial. Try that out, check you can declare double values. You can always put more of them in the same program as long as you give them different names, but do have a go at it. And we're going to look later on also at some general tips that you should use when programming and some tips for following this course. But at the moment, I'm just concentrating on getting you started with the most important things. Okay, so until next time, happy coding. Hello, in this video, we're going to take a look at arithmetic in Java. So we're gradually beginning to get towards writing something that really looks like a computer program and might actually be useful. So let's delete this. This is a copy of the program I was working on in the last video, and we've got in arithmetic, obviously we've got 4 operators that are very commonly used. We've got plus operator. These are called binary operators because they work on 2 values together. You know, like 3 plus 4, there's 2 values, so it's a binary operator. And the general name for these things is they're called operators. We've also got divide, and in Java the symbol for divide is a slash, like that. You have to get the right kind of slash. If you're going from left to right, you'd have to go up a hill. If you imagine sort of, I'm gesturing with my fingers, which of course you can't see, but it's like a hill sloping upwards from left to right. We've also got multiply, and in Java that's an asterisk. And in fact, these conventions are common in very many programming languages. And we have subtract, which is the normal sign you'd expect. It's a short dash like that. Let's try these out a little bit. So we'll have some variables. In fact, you can just use sysouts. Maybe we should also just do that to start with. And then we'll take a bit more of an extended look at this in the next video, I think. So if I write system.out.print line 7 plus 3, we expect to see 10. And of course we do see 10. There we go. We'll try some other things. We'll try all of them. So if we try 9 divided by 3, we should see 3. So we try this. So it says 3. Here's a surprise. If we do, let's say, 10 divided by 3, we run this, we still get 3. Why is that? Well, if you divide one integer by another integer, the remainder will be discarded. So you won't get back a floating point value. You'll still get back an integer value. So for example, 5 divided by 2 would be 2, because we're just discarding the remainder of 1. If you divide an integer by an integer, then the result will also be an integer. But you can use floating point values. So if I divide 10.0 by, let's say 3.0, then we'll get the answer that you might expect, 3.333 recurring. So you can see that with floating point values it works, and you get a floating point answer even if only one of your values is floating point. So for example, if we divide, let's say, let's try dividing 9 by 4.0. Let's try that. So if we do that, we should get, we get 2.25, 2.25. So that works because one of the values is floating point. One floating point value gives floating point result. Now what I've just done, what I'm actually doing here, which actually I should have mentioned, and I think I've maybe touched on it briefly, I have, but if you write 2 forward slashes like this, everything else that you write on that line is a comment. It's very useful to write comments in your code, but it's better to use them to describe kind of what you're intending to do overall, or what you've done overall. There's not much point putting a comment saying output 10 divided by 3, because you should learn that. You should learn to understand that just from seeing this code. And also, if you write a comment and then you change the code and you don't change the comment, you can seriously mislead yourself. So comments are important, but generally better saved for blocks of code where otherwise it wouldn't be clear what the intention of it is, for that sort of thing. We'll take another look at this in a video shortly, actually. Okay, let's carry on with this. So if I write sysout, let's try. So we've got plus, we've got divide. Let's try multiply. So 3 times 4. We expect that to be 12. There we go. It works. And of course subtraction. So let's do 3 minus 4. because that should give us -1. And if we actually run this, we see that indeed we get -1. So try all of those out for yourself and put some comments in as well, just to kind of describe what you're doing. Although they may be a bit overly precise, unnecessary at the moment, it's good to get into the habit of using comments a little bit. Try them all out, and don't forget to try integer division like this one, and assure yourself that it discards the remainder. It doesn't work quite as you might otherwise expect. Okay, and try floating point division as well. You can try all of these with floating point and integers if you can be bothered. Okay, so until next time, happy coding.